Welcome back. If you've ever set a default drop policy and watched your own apt update hang forever, this lesson is the fix. The first 4 lessons had us writing stateless rules where every packet gets judged in isolation with zero memory of what came before. The cure is conntrack. The kernel actually remembers connections and sorts every packet into one of 4 states: new, established, related, or invalid. Accept, established, and related up front, and 90% of beginner pain just disappears. So here's the roadmap for the next 10 minutes. 4 ideas, and you'll never write a fragile rule set again. First, why stateless thinking forces you to write everything twice. Request and reply, until your config becomes a swamp. Then, the 4 conntrack states themselves. The one magic established related line that kills 80% of your work. And finally, why invalid packets should always hit the floor before any other rule even gets a look in. Let's start with the failure that makes everyone Google this stuff in the first place. You set input to default drop, you open port 22, SSH works beautifully, and then apt update just sits there forever. The trap is subtle. Your outbound request leaves fine, but the package server's reply comes back as incoming traffic from some random source port 443, hits your input chain, matches nothing, and the default drop swallows it. The fix on the right is literally 1 extra rule: accept anything that's established or related, and suddenly everything works again. SSH still works, invalid still drops, 1 line. So why does that 1 line work? Because the kernel is already doing the hard work for you. Conntrack puts every packet into one of 4 buckets. New is the first packet of a conversation. Established kicks in the moment a reply comes back, so the connection is now 2-way. Related is the clever one. It's a child connection spawned by an existing one, like an FTP data channel or an ICMP error. And invalid is exactly what it sounds like: malformed, out-of-window garbage you should drop without thinking. Accept established and related first, drop invalid early, and then judge new with your actual policy. That ordering handles 99% of real firewalls. Let's watch those buckets in action with a plain SSH session. Packet 1 is the client's SYN to port 22. Conntrack has never seen this flow before, so it gets tagged new. The server's SYN ACK comes back, and right there the state flips to established. The conversation is now 2-way. The client's final ACK, every byte of your shell session, and even the closing fin all ride that same established label. 1 new packet at the start. Everything else is just an existing connection your accept established rule waves through. Now, new and established cover most of your traffic, but there's a 4th state that trips everyone up: related. It's for connections that get spawned by other connections, and you've absolutely hit this. Classic FTP opens a second data channel on a random port, totally separate from the control session on 21. Without related, your transfer just hangs. ICMP errors like destination unreachable come back tied to the original flow. Related. PPTP, SIP, IRC, DCC, same story. Rule of thumb: if the protocol predates 2005 and uses multiple ports, load the conntrack helper and accept related, or things break in confusing ways. Here's where it stops being magic. Conntrack isn't hidden. The entire state table lives in procnet nfconntrack, and pseudo-conntrack L dumps it in human-readable form. Look at the output. Your SSH session on port 22 marked assured. An HTTPS connection to GitHub, also assured. And a DNS query to 8.8.8.8 sitting in unreplied, waiting for Google to answer. When a rule misbehaves, don't guess. Read the table. The kernel will tell you exactly what it thinks is happening. So let's step back and ask the deeper question. Why is state the right abstraction in the first place? 3 reasons. 1. Connections are what humans actually care about. Packets are just the kernel's bookkeeping. 2. If you allowed the request out, You obviously want the reply back in, so encoding that twice is busy work that invites mistakes. And 3, anything that doesn't fit a known flow gets labeled invalid, which means a single drop rule swats away huge classes of scanning and spoofing tools for free. With that settled, here's your printable cheat sheet, the whole lesson on one page. Left column. The states you'll actually meet in the wild, from new through invalid down to the SNAT and DNA translations. Middle column. The 3 rules that should sit at the top of every chain you write. Accept established and related, drop invalid, accept loopback, then your real policy below. And on the right, the conntrack debug toolkit. -L to list, -C to count, -E for a live feed, plus the proc files when you need to check or raise the table size. Stick this on the wall next to your terminal. Now you actually do it. 3 short drills, and please, before any of them, set that 2-minute rollback in the hint, because you will lock yourself out otherwise. Drill 1, reproduce the apt update hang on a default drop box, then watch the magic established line bring it back to life. Drill 2, open conntrack-E in one window, curl something in another, and watch entries flip from new to established in real time. Drill 3, drop invalid at the top of input, then come back in a day and check the counter. On a public box, it will not be 0. Once you've done those drills, you'll start recognizing the same 5 failure modes everywhere. The big one is still number 1. Default drop with no established rule. SSH works because you whitelisted port 22, but every reply packet to your outbound traffic gets silently killed. Number 2 is putting established last instead of first. Remember, -I1 inserts at the top, -A appends. 3, forgetting related, which is why ping and FTP mysteriously break. 4, not dropping invalid early before any accept can catch it. And 5, the one that bites busy public servers, conntrack table overflow, where new connections just vanish and DMSG quietly tells you why. And that's lesson 5. State is remembered, replies flow, and you've got the 4 pillars: new, established, and related for the good traffic, invalid always dropped, the magic first rule pinned to the top, and conntrack-L whenever you need to peek under the hood. Next up, lesson 6, the order matters, where we dig into why iptables reads top to bottom, how default policy sits underneath everything, and the right way to insert, append, and reorder without locking yourself out. See you there.